This is the video for after school extra credit on Wednesday. Since I have a meeting in my room, in order for you to get the extra credit for it, you're going to need to have your 2013 practice test out. And I said to use a different color on it. Well, you go through each one. So even if you've already done it, just do what I do in some other color, and then you can just show it to me on Thursday. So number 76, the rest of the ones on out here in multiple choice are calculator active. So you should have your calculator out because I am not going to use mine on purpose. I won't finish all of the ones that actually need to have input into the calculator. First question with number 76 says that G is accumulating the area under the curve of F. This is the graph of F, and we're supposed to accumulate from 0 to 5. So this is a nice, easy area of the curve. It'd be the area of the triangle, which is 1/2 of its base times its height. So that would be 1/2 of 1 times 3. It's positive because we're above the x-axis. So we would do 3/2 plus, and then we do the area of the circle. It's pi r squared, but this is a semicircle. So this would be a positive 2 pi since it too is above the x-axis. So I'd have 3/2 plus 2 pi, which gives me the answer of D. No calculator even necessary for that one. Number 77, a related rate. Volume of a sphere is decreasing at a constant rate of 3 cubic centimeters. I would write that down in its calculus notation with dV dt equaling -3 because of the decreasing rate. At the instant when the radius of the sphere is decreasing at a rate of 0.25, dr dt equaling -0.25 or -1/4, again because of the decreasing nature of it. What is the radius of the sphere? So I'm looking for the radius. In order for me to get going, I need a formula that kicks this off, and they gave it to me, which is nice. I didn't have to have it memorized. So just using my formula for volume of a sphere, I will start taking dV dt. That's what I have some information about. dV dt will equal, bring the 3 out front, it'll cancel, knock the power down 1. Don't forget the derivative of the guts, which is dr dt. I'm supposed to find the radius of the sphere at the instant when dr dt is -1/4 and then dV dt is -3. So I'll go replace those. -3 would equal 4 pi r squared times -1/4. 4's will cancel, negatives will cancel. Sorry, I canceled the 3 off there. The negative will cancel, leaving me 3 equaling pi r squared. So I would have to do 3 divided by pi and take its square root. And you'll need to finish that one off in order to get credit. So again, for you to get the extra credit test points, you need to write down everything I've written in a color that's not the same color you used when you took the practice test. Number 78 is both easy and difficult. It's really just arithmetic, but you have to decipher all of the notation. We have 2 continuous functions, and the area under the curve from 0 to 10 of one of them is 21. If I were to make just a fake sketch, this could be f. This could be f from 0 to 10 right here, and it could have balanced out to be positive 21 in area, and g doesn't necessarily need to be the same shape, but I'm just making a for instance graph. G on that, half of it was 8, which means it was 16. So that's what they've told you, is that from 0 to 10, you've got 2 functions, one that's accumulated 21 positive units of signed area, and one that's accumulated 16 positive units. And again, it's the 16's coming from that 1/2 multiplier out front. They tell me that the integral from 3 to 10 outright is a 2 of the difference, and they ask me for 0 to 3 of the difference. Well, here's what you have to figure out, that to go from 0 to 3 under the curve, and I'm going to use bad notation, first you're going to have to go from, let's go like this, let's go from 0 to 3 plus from 3 to 10 is going to have to equal the whole way from 0 to 10. And again, my integrand in this scenario is f minus g. Really what I'm just saying is that 3n plus the rest of the way has to equal the whole way. Well, what am I trying to figure out in this one? I'm trying to figure out this. Just because it's multiple choice, I'm going to call that X. I don't know what that is. They outright told me the area under the curve of the difference from 3 to 10 is 2. And then I can use this information to figure out what the whole way must have been. If one was 21 and one was 16, the difference must have been 5. So when I solve that, I get a 3. That one's tricky, but it's really just arithmetic. So decipher all this notation, maybe draw a sketch, and that becomes a pretty doable problem. Number 79, and this is what happens a lot on the AP exam, is although you have a graphing calculator, really on the graphing portion, you do a lot of interpreting graphs. Notice I haven't even referenced using a graphing calculator yet. You usually don't need one. When you do, you need to know how to use it. But this is just graph interpretation. So I've got a graph of f prime, and let's take a look at what f prime's doing. F prime is positive, which means f must increase until it gets to 2. And then, because f prime is negative, f must decrease. What does that tell me about 2? There's a relative max on my graph. So this one's out, this one's out. Just by analyzing the first part of the graph, I only have 2 of them that have a relative max at 2. So let's go take a look at the rest of the graph and see what needs to happen. I also need to have a second derivative right here of 0. I have an inflection point there. Kind of looks like I have one right here. It looks like there's a little change. There totally isn't a change in concavity there. So I don't even need to go any farther. Just analyzing the first part of the graph of f prime leads me to C. I would increase, hit a relative max, decrease, hit a relative min, and then increase again. I'd have inflection points at 1 and another inflection point over at 3. So that one's pretty easy to decipher. Again, no calculator necessary yet. Number 80 is kind of testing notational fluency and some particle motion stuff. This question's usually one of the most missed types of questions. It says for the time t, the position of a particle is given by the function s. S is increasing from 0 to 2, and s is decreasing after that. It says which of the following gives you the total distance. So you need to take and remember your total distance formula. You integrate across the entire way and you integrate the velocity because every time you go backwards you want it to count as forward movement. That's not here. That doesn't mean you go guess. It means it's there in disguise. So what they've done is given it in terms of s. So just go right here. This thing that you're not finding over here is actually over there because the velocity function is really the derivative of position. So by replacing velocity with its derivative format leads me to E. Some of these others, just to interpret what they are, this would be the position at the start plus the displacement for the first 2 seconds minus the displacement here. These are going to tell me where I am, not the total distance traveled. So the next one up, you always get a question like this where you're given a rate. There's usually something there at the beginning, so you need a starting amount, but this is a cup of tea cooling in a room that has a constant temperature of 70 degrees. The initial temperature of the tea is 200. That's important because then they're going to give you some rate at which it's changing. And here it is. The rate that the tea is changing is given by R of t degrees per minute. What is the temperature? So I need to go from degrees per minute back to temperature after 4 minutes. Well, it didn't start at temperature 0, it started at 200. And then it was changing at a rate of R of t. So I don't just add R of t on here. That was in degrees per minute. And I need to know the total change in degrees. So this is an integration problem. I will need to integrate from, on this one, 0 to 4. And I will leave you that one to do on your calculator. But again, there's always one of these rate problems. Where am I at the beginning? And then how much am I accumulating? In this case, we're accumulating temperature, degrees per minute times minutes, add it all up, gives me a change, net change in temperature after I start at 200. I don't know what that is. That's up to you to go enter that on a calculator. Number 82. I'm given the derivative of a function, which is nice. And again, we're calculator active right now. So I would immediately go enter that in your y1. I would go set your window maybe to go from -3 to 3 by ones. And then again, pause this while you're entering stuff on your calculator. I will not actually answer the question. I'm just going to lead you to it if it's calculator active. At which of the following values does f have a relative maximum? Well, we need f prime to change, and you should have this written on your sheet, from positive to negative. Well, if I'm staring at the graph of y equals f prime, then I need the graph to cross the x-axis from positive to negative. So you're going to go enter this in y1. Set your window to go from -3 to 3 by ones, hit graph, and you're going to look for wherever we change from positive to negative, whether that's once, twice, 3 times, I don't know because I'm not graphing it. You're going to have to wrap that one up. There must have been another one at the bottom of this page here. Number 83, also calculator active. I don't know if it'll help you yet or not. This is actually what we discussed in class on Tuesday when we did the Wednesday when we did the Riemann sums. This is giving you selected values along a curve, and it says which of the following could be the exact value. You don't know what the exact value is because you don't even know the function. If you had the function, you could just integrate it. You could by hand use the antiderivative, but this is calculator active, so you could math 9, but they didn't tell you what f of x is. But they want you to figure out which one could it be. It's their way of saying, is there a way you can approximate it off that grid? So we talked about our 4 approximation methods, right, left, midpoint, and trapezoidal in class on Wednesday. This is an increasing function. You can see it. A right on an increasing will give you an overestimate. A left on an increasing will give you an under. So if you calculate both of them, your answer has to be in the middle of those. And again, I'm not going to calculate them. You're going to go do that. But if you were to do the right Riemann sum or a right rectangular approximation method, you would go figure out the base of all your rectangles. It's nice. It's consistently a half. And then you're going to stick to the right. And you do 4 plus 10 plus all the way on out to 54. And you're going to get an approximation for the area under the curve. That's an overestimate. Then you're going to do the left rectangular approximation. So you're going to start with the left and never hit the one on the far right. It's going to give you an answer. You need to pick a value between these two. There must be only one of them. So I know it can't be that one or that because those are the two biggest. You'll have to wrap that one up on your own. Number 84. Sorry, something made me laugh. Number 84, nice easy reading of a graph. And again, we're calculator active, but it's really not helpful. They do that on purpose because the TI-89 can do pretty much anything you can program it to do. Also, there's computer programs that people have written that are easy to find online that do almost everything. So if you're using a calculator, it's really for one of 4 things on the AP test. You're either calc zeroing, you're either calc intersecting, math 9, or math 8. Nothing else really. Again, this is calculator active, but I'm reading a graph, so what good does it do? Here's a graph, and it says, which of the following must be true? Is f of a equal to 2? Definitely not. F of a is equal to 1. That's where it's defined. Is f continuous at a? No, I have to lift my pencil. Do I arrive at 1 when I approach a from both directions? No. I arrive at 2. Is the limit as I approach f from a from both directions 2? Yes. And the limit does exist. Again, just because there's a discontinuity does not mean you don't have a limit. What number was that? That was 84. So I've got another one hiding down here somewhere. This one I would use my calculator on. Particle motion and calculators go really well together. A particle's moving along the x-axis so that its position, notice they had another one where they called position S. They want you to be fluent with both notations for position x of t and s of t. What is the velocity of the particle? Remember, velocity is the derivative of position. So I need to do the derivative with respect to x of cosine, and we can just do root x, right? At the minute when the particle is first at the origin. Well, that I have to go figure out, because if you're at the origin, your position is 0. So you have to set 0 equal to cosine of the square root of t or x, whatever I'll just keep the t going in here just for the heck of it. But you have to figure out what's going to cause cosine of the square root of t to equal 0, because that's when you will first be at the origin. Now, you have a couple ways to do that. You could actually just graph your x of t function and see when it's at 0. That's totally possible. Or you could solve this. The cosine of what equals 0? Well, when you're thinking of your unit circle, the cosine of pi over 2 is equal to 0, correct? So I need the square root of t to equal pi over 2, which means I need t to equal pi squared over 4. Now, if you had graphed this and kind of tried to figure out when that position was 0 and done a calc 0, you'd get the decimal version of that. But I don't have my calculator out, so I'm keeping it real here. Now, do the derivative. Although you know how to do the derivative of this with the chain rule, your negative sign times the derivative of the gods, etc., your calculator will do it if you can tell it where. And again, you're going to math 8 that, and I'm going to leave it up to you. I have no clue. I don't have a key sitting out with me, but there's the mechanics to get the right answer for number 85. Moving on for number 86. No calculator helpful. I'm reading some tables. So we have to decipher what they're telling me and what that will allow me to conclude with these tables. If f prime is greater than 0, then f must be increasing. So the first thing I'm going to go do is see, are you increasing? No, f is going down. No, f is staying the same. And then we've got increasing all the way, increasing, increasing. So that outruled 2 of them. If the second derivative is negative, that means f prime, which are the slopes, must be decreasing. So I will go find some slopes and see if they are decreasing. Slope here, change in y is 1 over 1, 1 over 1. They're staying the same. I need it to decrease. This would be 1 over 1. This would be 2 over 1. That one's got slopes that are increasing. This one would be 2 over 1. Again, I'm just doing change in y over change in x from my 6th grade years here, right? Only letter E has a decreasing chart for f, right here. I'm sorry, increasing f and decreasing f primes. So the answer to that would be E. 87, this one you would need a calculator for, otherwise it'll take you a very long time. Go enter this in Y1, and I should see that written on your test. How many relative extrema? Relative extrema occur where f prime changes sign. It doesn't specify maxes or mins, so it can change from positive to negative or negative to positive. And you're going to be looking at the graph of f prime. So you need to enter that. You need to set your window from -4 to 2 by ones. And then you're going to hit graph, and you're going to count how many times that thing slices through the x-axis. And again, I don't have a calculator, so I don't know how many, and I don't know the general shape of the graph. But remember, just in case, if there's ever a bounce, that does not indicate a relative extrema. It's a critical value, but it's one where a plateau exists. I don't know. Actually, somebody's in here working their calculator. I'm going to have her do it for me, and I'll come back. I don't know if that one bounces or not. My guess is not, because they're usually not that thorough on the AP test. Like, it'll just slice through definitively like 6 times or something. But we'll come back to that one once my assistant here is done typing that into her calculator. Number 88, do you know what f prime really means? Let's take a look. This graph is a twice differential function. Which of the following is true? All I'm doing is comparing f primes. I'm just comparing slopes of tangent lines. And I'm doing it at 1, 0, and -1. So let's pull that out here. F prime at -1 is the slope of the tangent line there, which is 0. F prime at 1 is the slope of the tangent line there. I don't know what it is, but I know it's negative. F prime at 0, I don't know what it is, but the tangent line is positive there. So I'm comparing 0, negative, and positive. Which of the following is true? You can go ahead and find it in there. I don't want to. I just did all the work for you. 89 is next. This is this a volume one? Yes. So we need to sketch a graph. Might be a little tricky for some of you because it doesn't say y equals. Well, you can't recognize the graph of your parent functions and tell it says y equals. So we'll square both sides. We'll add 2 on, and again, you should be writing this down. That's a parabola. It's the right-hand side because it says x is the positive square root. So it's the right-hand side of a parabola that hits here at 2 and continues on up. What is the volume of the solid generated when the region bounded by the graph x equals 0 and y equals 5? Y equals 5 is up here. X equals 0 is right here, and the graph is right here. So the region in question is actually up here. It's something comma 5, and this is something 0 comma 2. And I want to know what the volume is. This is going to probably be best done by revolving. Well, how am I supposed to revolve? Around the y-axis. This is a dy problem. Let's go put that little rectangle on there. Let's go put that dy. And I'm not building up off of it. I'm revolving. So let's put our formula for revolving down there. It's all about the cylinder. It's pi times the integral from big R squared minus little r squared, which in this scenario is 0. It's a disk problem. This is a dy problem. I will climb up the y-axis, so my limits will be from 2 to 5. The question is, what's r? Well, I go right minus left. I need the x value there, and they told me it's the square root of y minus 2. So right here, I do the square root of y minus 2 quantity squared. And again, I don't know what one that is, but you've got a calculator. My guess is one of these answers they did from, they had the wrong limits. One answer is the answer if you hadn't remembered pi. My guess is one answer is if you hadn't remembered to square it. Everything you're going to do wrong, they anticipate. So it's a little bit deadly. But again, you go to your calculator. This problem is from our exponential growth days, which we haven't done a whole lot of review on. A population grows according to the fact that the rate of change of the population at any given time is directly proportional to the population there, which means the more people who are there, the faster it's going to grow. That totally makes sense. It says if the population of the city doubles every 12 years, what's the value of K? Well, it's talking about the population, and I'm being given the derivative or the rate of change. I need to figure out what P is. And you need to remember that for these exponential growths, it's always y equals C e to the K T. You could separate, integrate, all that stuff, but it's a waste of time. It always works this way when you have that constant of proportionality right there. This will give me the population at any given time. Now, it didn't tell me how much I had there at the beginning, but it told me it doubles. So whatever this was, let's call it P sub 0, this would have been twice it. You can make up a fake population and say it started at 100. Well, then it's going to grow to 200, and you would still cancel and get a 2. So whatever that start was, it grew to double it. So I really have 2 equals e to the k, and how long did it take to double? 12 years. I'm solving this for k. So I natural log both sides. It'd undo the e. and I'd have ln2 divided by 12. And again, I'll leave that to your calculator, but really there's always a question where you're given the rate of change of something over time is directly proportional to the amount present. That always evolves into B equals C e to the kt, where c represents the amount at the start. And if something's doubling, well, then I'd get twice it. If something was tripling, then I'd have a 3 here. If it was a half-life, then if it was b sub 0, it would go to a half of b sub 0. So you need to, that one's tricky. Two more, whew. Number 91, let's see what we have here. The function f is continuous, and they give me a value of f from 0 to 8. Well, that's kind of weird because they're asking me from 1 to 3. This is totally u sub. You can see it. They went from an expression involving all x's to an expression involving all u's. You need to know who u is. Well, it's the inside function. U is x squared minus 1. I now have f of u. Du is 2x dx. Crap, don't want the 2 there, half it. So that x dx is going to be replaced with 1/2 du. So I have 1/2 the integral of f of u du, and I need to make sure that I change my limits, and that's why you'll notice that it was at 1, 3, and then all of a sudden it's at 0, 8. Well, that's because with a limit change, remember, you have to be, everything's in terms of u. So that evolves into the 0 that it says it's supposed to, and when I do a limit change with the 3, it'll go up to 8. So my answer will be 1/2 of 0 to 8 f of u du. Well, that's going to have to be 3. So again, this should prompt u sub when you see an expression involving x, an expression involving u. You can see the limits have been changed. Straight up u sub. Last one is referencing a very obscure theorem way back from when we started working with maxes and mins. A function f is defined, so it has y values everywhere from a to b, if it does not attain a maximum value. So they're saying you have some f of a and some f of b, and you connect them. Sorry, that should be a f of a, whatever, b f of b. When you connect them, you don't reach a maximum. Well, that seems kind of weird. Like, don't you have to reach a maximum? And the question is, yes, you do, as long as that would have a maximum. This would have a maximum, has a maximum as long as the function's continuous. But if I put an open dot right there and I ask you what's the max, you can't tell me because you can't get there. It's called the extreme value theorem, and its hypothesis says that as long as a function is continuous, doesn't need to be differentiable to have a max. I can max out or min out at a cusp, but the function has to be continuous for me to obtain a maximum on it. So where's the one about continuity? It's right there for part A. So just lastly, before I leave you on this one, we have 3 existence theorems that you need to be familiar with. The extreme value theorem, which basically says what I just said. As long as a function's continuous, it guarantees that there's got to be a place where you have a max and or a min. We also have the mean value theorem that says as long as a function is continuous and differentiable, there must be some place where the slope of the secant line, f of b minus f of a over b minus a, has to equal the slope of the tangent line, f prime of c. This requires continuity and differentiability. This requires continuity only. And our other one was the intermediate value theorem. That one too only requires continuity. So this is continuity, 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 and differentiability. And the intermediate value theorem says that as long as a function's continuous, if you travel from f of a to f of b, you have to hit every y value along the way. It's usually used to verify zeros. Like you'll plug in one number and you'll get a positive, a negative. They'll tell you the function's continuous, and they'll ask you, does there have to be a place where the function's value is 0? And you'll say yes. Whew, that's it. Have a good one. Uh-oh. Oh, how many times did that graph pass? It passed 6 times. So that's it. Perfect timing.